generally we need accurate reading as well as we need precise reading. See, if you remember our discussions yesterday, always we measure the capability using two parameters. One is central tendency, another one is variation, isn't it? Central tendency should be on the target. Central tendency should be on the target. If your central tendency is on the target, then you are accurate. At the same time, if the central tendency is on the target, it doesn't mean that all your data points are on the target. No, your average is on the target. Still, your data points can have spread. If you don't keep an eye on the spread, if the spread increases, what happens? Some of your outputs may go beyond specification and then get rejected. So same logic is applicable for the measurement of measurement error also. So by accuracy, by bias, we measure the percentage accuracy. But when we actually look at individual readings, there could be inconsistency. And there are two forms of inconsistency. One is called repeatability. Another one is called reproducibility. One is called repeatability error. Another one is called reproducibility error. When I say repeatability, it is good. But when I say repeatability error, it is bad. Similarly, when I say reproducibility, it is good. But reproducibility error, it is bad. When this repeatability and reproducibility comes, whenever we go for multiple reading, then this error comes into picture. For example, imagine I myself measure a product multiple times. The product characteristics is, let us say, diameter. The diameter is 100 mm. I measure it multiple times. Do you think I will give all times I give the same reading? I'm going to do an experiment with all of you. Right? So when I ask you to measure a same characteristics multiple times, it is quite obvious that we give different reading. Possible, isn't it?
Yes.
When your readings are different, though you are measuring the same part, same characteristics, using the same measurement system, the same methodology, same appraiser, but your readings are different. This variation in your data is called repeatability error. Hope all of you are able to understand what is repeatability error. The error within the readings of single appraiser is called repeatability error. Another thing. What is the other thing? Reproducibility error. Suppose imagine I engage multiple appraiser. I collect data and then you also collect the data. So what I am measuring, you are also measuring the same thing. Let us say the product characteristics is 100 mm. I measure and then say, the reading is 102. 100 is measured as 102. And you are saying that reading is 103. Now what happens? There is a disagreement between the appraiser. For reasons, I engaged two appraiser. But these two appraisers, they don't agree to each other. But both of them are doing the same job. They are on the same project. They are using the same equipment. And everything is same. But only thing is their reading differs. This form of error is called reproducibility error. The difference in the readings between the appraiser is called reproducibility error. The difference in readings of the same appraiser is called repeatability error. Is that all of you understand what is repeatability error and what is reproducibility error?
Yes, sir.
I want one of you to read out the definition of repeatability error. Little louder. Who can do that?
Repeatability is the consistency of a single appraiser to measure the same part multiple times with the same measurement system. It is related to the standard deviation of the measured values.
Okay. So let us say now our appraiser is Hastimal Padia. Am I correct, sir, with your name, right?
Yes, sir.
Hastimal. Yeah. Yeah.
Yes, sir.
Okay. So Hastimal is measuring data, right? Collecting a data, and he is so consistent. He's so consistent means he measured 10 times, and all 10 times his readings are same. The product, see, we need to understand now, we are not concerned about the accuracy because the accuracy Vinod has explained. Now I am really concerned about the consistency. The product value is something, let's say 100 mm, and Hastimal collects the data 10 times, and all 10 times he gives the same reading. Let's say all 10 times the reading is 100. Now when you have all numbers exactly same, what is the amount of variation that is present in the data? Amount of variation is 0. Am I right?
Yes, sir.
When amount of variation is 0, that's the time we consider HTML as consistent. Isn't it? When the readings are consistent, he is highly repeatable. But the moment the reading starts differing from the previous reading, or if there is if the variation populates, that's an indication that repeatability error is also populating. Am I correct?
Yes.
Isn't it? So if 10 readings, all 10 readings are 100, the highest value is also 100, lowest value is also 100. The difference between highest and lowest is 0.
0.
If the range is 0, repeatability error is 0. But this situation will never happen. If you take multiple reading, there will be lowest value, there will be highest value. And that difference, which is the range, when when actually acquires some value, and you can understand the repeatability error is populating. So you can measure variation either using range, and the better way of measuring variation is using standard deviation. Using standard deviation. So it is important to understand what is standard deviation. Any set of data will have a central value. What is central value? The mean value. You all know what is mean. You add all the value, divide by the number of data, that is the mean. You call it average. Now, each of your data point will differ from the average. Am I correct? Each of your data point will differ from the average. This is called deviation. This is called deviation. Each of your data will differ from the average value. That difference is called deviation. You square the deviation. Square the deviation for all numbers. Sum them up. Divide by the number of data. And then now you take the square root. The resulting figure is called standard deviation. Right? You don't worry about the formula of the standard deviation. We all have studied in 7th standard. I have explained it in the white belt module number 2. So, sigma equal to square root of summation of x minus x bar the whole square divided by n minus 1. This is the formula for standard deviation. Either you measure the variation through standard deviation or through range. That will help you to estimate the amount of repeatability error. That is the meaning of the last line read by HTML. It is related to the standard deviation of the measured value. All of you are now able to understand?
Yes, sir.
Right? If the standard deviation is low, HTML is repeatable. If standard deviation is high, HTML data has repeatability error. Now, how to estimate the error? How to estimate the error? The kind of curve what you are seeing in my slide, the bell-shaped curve, is called the normal distribution curve. Whenever you see your data appearing like a bell shape, it's a normal distribution curve. And once you understand your distribution is normal, you can actually calculate the central value. You can see the center line here. Let me bring my you can see the center line here, isn't it? The center line is nothing but the mean of the readings. The center line is nothing but mean of the readings. And using the set of readings, you can also calculate what is called the standard deviation. You are seeing here the standard deviation. When the standard deviation is larger, your curve will become wider. When the standard deviation is larger, your curve will become wider. See here, you have by one standard deviation, you have come up to this distance. You go for one more standard deviation, go for one more standard deviation. If you go for 3 standard deviation, major portion of the area under the curve will be covered. How many of you understand my statement? If you go by 3 sigma distance, if you go by 3 sigma distance, the major portion of the curve is covered. So generally, for estimation purpose, we go up to 3 sigma distance from the center value, which means your deviation at the maximum can go up to 3 sigma only. Now, 99.73% of the deviation can be understood if you go up to 3 sigma distance from the center value. So 3 sigma on the right side, 3 sigma on the left side. So total amount of deviation is 6 sigma. When you calculate sigma and multiply by 6, that will give you an estimate of the total error, because sigma itself is a measure of error. And in the whole distribution, how many sigmas are there? 6 sigmas are there. So this sigma multiplied by 6 will help you to estimate the amount of error. But we need to understand one thing now. We have not collected the entire amount of data. We have collected only a sample of data. But just with the sample data, I am trying to estimate what will be the total amount of error my team may commit when they actually collect the data. Right? Because we are doing an inferential statistics. Through sample, we are trying to understand the reality. Right? So that is about the repeatability. And now, Hastimal sir, you all please go for the reproducibility also. Please read it out.
Yes, sir. Reproducibility is the consistency of different appraisers in measuring the same part with the same measurement system. It is related to standard deviation of the distribution of appraiser averages.
Fantastic. Now, there are some appraiser. I am one of the appraiser, and Astimal is other appraiser. Anand Raj is another appraiser, and then Vivek Kumar is another appraiser. There are 4 appraisers. Now, I collect reading, multiple reading. I will have an average. And Hastimal, multiple reading. Hastimal also have an average. And now Anand Raj also has multiple reading. He will have an average, and Vivek Kumar also will have one average. Now 4 appraisers, I have 4 appraisers, I have 4 averages. What is required is, we 4 of us should agree to each other. How do I know whether my average and Hastimal average and Anand average and Vivek Kumar average agree to each other or not? If there is a difference between the averages of the appraiser, that is a reflection of the reproducibility error. And that is why the last line goes like this. It is related to the standard deviation of the distribution of the appraiser's average. You can see here. And now there is here. This is first appraiser, maybe myself. This is my average. And this is Hastimal's average. And this is Anand Raj average. And this is Vivek Kumar's average, and so on. And for all the average, I can have a grand average. With respect to the grand average, I am plotting the appraiser's average. Some of the appraiser's average will be on the left side of the grand average. Some of the appraiser's average may be on the right side of the grand average, and I can see a bell distribution again. Now this distribution is distribution of the averages. I am not using individual data. I am using only the average of the data. And now using, now in my example, there are 4 averages. Using these 4 averages, or whatever is the number of appraisers, I will calculate standard deviation. So this standard deviation, when multiplied by 6, will give you an estimate of the reproducibility error. Our goal is repeatability error as well as reproducibility error. Both put together should be minimum. Both put together should be less than 10% of the working range. We will understand that by going through further slides. And you can actually do the gauge R&R study in Minitab. And see here in Minitab, when you go to stat and quality tools, go to stat, go to quality tools, and then there is an option for gauge study, and then you can create a sheet for gauge R&R study. Creating a gauge R&R study means you will get a data collection plan, right? And then you can actually see here, Minitab will create something like this. Part number indicated, operator number indicated, or operator name, and run order is also given, and then measurement, which means I'm planning to collect about 30 data. And how many parts are there in my study? 5 parts are collected. But in my suggestion to all of you is, minimum you should be able to take, you should take 10 parts within your working range. This is for illustration purpose. I have taken 5, but actually to get to know the ground reality, I suggest you take minimum 10 parts within your working range, and then the number of operator depending on the requirement. If you in your project, if you are going to use 3 operator, better involve the 3 operator, right? If there are so many operators, then make a random choice of 2 or 3 and then collect the data. All right. And now we'll do an activity now. We will do an activity now. And I hope all of you have your mobile phone. Am I right? Yes. So we will use your mobile phone as the measurement system. We are going to measure time. In order to measure time, I require a stopwatch. I think all your mobile phone will have a stopwatch. Please open the stopwatch and then tell me what is the resolution of your stopwatch. Resolution is nothing but the least count. Least count is nothing but the lowest possible reading. Least count is nothing but the lowest possible reading. Can you all please share the least count of your mobile? Because I wanted to be sure all of us use the same measurement system. How much is the least count? Come on, please.
Hundredths of a second.
100th of a second. Beautiful answer. 100th of a second. Very good. Or otherwise you can call it 0.01 second. 1 by 100 is 0.01. All right, 0.01 second. So that means any reading you people are going to give me will definitely have 2 decimals. And we are going to measure time, which is nothing but duration of a song you are going to measure. What is that you are going to measure? Duration of song, which means I'm going to play a song from my side. The moment I play the song, you can listen, you can hear. The moment you hear the sound, you need to start your stopwatch. I'm sure all of you know how to start the stopwatch. The moment you hear the song, you start the stopwatch. And then once the song comes to an end, you stop the stopwatch and then give me the reading. Is my operational definition, enough? Is clear? Clear and concise statement about what we are going to measure is very important. Otherwise, what will happen? Each one will measure in a particular way, and that will become the reason for the error. So we should not give any room for the error. Hope all of you have understood. And now I want a few people to participate in the activity. So I'm going to collect their names. Maybe all the teams or whoever interested, you can participate. And who are all interested and who are all I can see on video, probably I will include their name. Yes, Vivek Kumar is there always. And who else? Come on, please tell your name. Okay, I will have Hastimal also. Okay, then these are appraisers. Come on, spell out your name. I am just, so that I don't have to. What's your name?
Anand Kumar.
Arun Kumar.
Anand Kumar.
Oh, sorry, Anand Kumar. Okay, Anand Kumar is another appraiser. And I can take, few more. Surendra. Okay. Surendra. Then, 5th appraiser. Come on, you can participate.
Yes, sir.
Subir Manna, sir.
Avik Ghosh.
Subir Manna, sir.
1 second. First, I will take Avik Ghosh. Then,
Subir Manna.
who said?
Junai Martin.
Okay, Junai Martin. Okay, Junai Martin. Then,
Subir Manna, sir.
Sunila.
Subir Manna, sir.
Subir Manna. Why don't you switch on your video? We want to see you. How are you collecting data? Right. And then, any more interested? Enough? Okay. So with these people, we will do the activity. How many appraisers we have? 1, 2, 3, 4, 5, 6, and 7 appraisers we have. So let us go for the activity. All of you keep your stopwatch ready. So I'll play these songs one by one, and you are going to give me the readings after hearing the songs one by one. Are you ready? Shall we go?
Yes, sir.
And first confirm me whether the song is audible, because I'm not very sure.
तू मामा बन सकता था तेरी झलक का शर तू मामा बन सकता था तेरी झलक का शर्फी तू मामा बन सकता था
So audibility is good, right?
Sir, audible, sir.
It's good, sir.
So we go for it now. We go for it, right? Be ready. 3,
Yes,
2,
sir.
1, and here we go.
तो तू मामा बन सकता था तेरी झलक शर्फी सिवली नैना मदद बर्फी तेरी झलक शर्फी सिवली बातें करे
So how is this song? Song is good, right? Let's see how the reading goes, right? We'll correct your reading now. Just a second. Yeah, we'll correct your reading. Yes, one by one.
Astimal 20.73.
Astimal, okay. Astimal 20.73.
73.
And now Vivek Kumar
19.15.
19.15. And then Ananda Kumar
19.28.
19.28. Then Surender
21.51.
21.51. Avik Ghosh
20.25.
20.25. Then Junai Martin
21.09.
21.09. Then Subir Manna. Subir Manna. What happened? You have not
21.13, sir.
20.
21.13.
Okay, 21.13. And now, do you see variation in the data?
Yes,
Yes,
sir. Mine is 19.22.
19.22.
Sir, this is
So you are
Tangatha,
also there,
minus
right? Kirti,
18.65.
right? Okay, I'll include you also. Okay, Kirti, Tripathi. And how
Sir,
much
this
you
is
said?
Tangatha, madam.
19.22.
22.
Yes.
And now one more appraiser is coming.
This is
Tangat
Tangatha, madam.
Tamilana. Okay,
Yes, sir. 18.65.
18.65. And now do you see variation in the data?
Yes, sir.
How this variation is populating? We had clear, operational definition. We all had the sophisticated smartphones. We used the smartphone as the stopwatch, which had the, resolution of 0.01 second. But still, we could see a variation. What is this error called?
Reproducibility.
People to people change, will change, sir.
Reproducibility, sir.
Reproductive error.
Repeatability or reproducibility?
Reproducibility.
Reproducibility, sir.
This is variation. Variation is the error. This error is reproducibility error. The disagreement between the appraiser. Disagreement between the appraiser is called reproducibility error. In the first run itself, we have noticed population of reproducibility error. And now we'll go for the second run. So all of you can reset your stopwatch. We now go for the second song. Are you ready, all of you?
Yes.
Yes, sir.
Three,
Yes, sir.
2, 1, and here we go. Okay, it's a much better song, I believe. Right. So now for the song 2. Let me. I want to go in the same order, starting from Vivek Kumar. Yeah, Vivek Kumar, you are reading.
30.66.
30.66. Then Hastimal
29.37.
29.37. Then Ananta Kumar
30.30.
30.30. Then Surender
30.30.
30.30. Then Avik Ghosh
30.32.
30.32. Then Martin
30.18.
30.18. Then Subir
29.15, sir. 29.15.
15. And
Yes,
Kirti Tripathi
29.61.
29.61. And then Tangatamilan
30.01.
30.01. And now look at the second column, song number 2. Do you still able to see some variation?
Yes, sir.
What is this error again? This is again reproducibility or repeatability?
Reproducibility, sir.
This is again, reproducibility error. We are seeing, the variation vertically, and this is again reproducibility error. So let us collect all the data and then talk about the error. Now we are proceeding with the third song. Okay. Ready? 3, 2, 1, and here we go. So readings, right?
हाँ, तो
So again, we'll go in the same order. Yeah, Vivek Kumar, you are reading
37.80.
37.80. Then Hastimal,
39.75.
39.75. Then Ananda Kumar,
39.42.
39.42. Then Surender,
40.48.
40.48. Then Avik Ghosh,
30.23.
30.23.
No,
Okay.
38, sir. 38. 38.23.
38.23. Then Junay Martin,
40.00.
40.00. Then Subir Bhatta,
39.42.
39.42. Then Kirti Tripathi,
38.03.
38.03. Then Tangatamilan,
39.89.
39.8. So again, you can see population of the measurement error. This is what I said. You just cannot, eliminate measurement error. It will be there. So it is very important to keep an eye, very important to understand how much it is, and then we must take measures to control them. If you can limit it to less than 10% of your working range, your measurement system is really, sound. So we'll go for the fourth song, and those of you who can dance, you can dance along with the song. We'll go for it, right? So yes, same order, starting from Vivek.
51.15.
51.15, then Astimal,
50.23.
50.23, then Ananta Kumar,
50.32.
50.32, then Surender,
50.36.
50.36, then Avik Ghosh,
49.26.
49.26, then Junay Martin,
50.28.
50.28, then Subir Manna,
49.75.
49.75, then Kirti,
50.11.
50.11, 11. Okay, Tangatamilan,
Yes.
50.1.
50.10, right? So again, the fourth column also has some variation, which means again, there is some error. Once again, it is the reproducibility error, right? So if you sum up all the errors, it should be less than 10%, and which we will see how we can calculate. Are we ready for the last sum?
Yes, sir.
Yeah.
Yes.
So 3, 2, 1, and here we go. So the data collection again in the same order, starting from
58.81.
58.81. Okay, Astimal,
1 minute and 0035.
you mean to say 60.35?
Yes, sir.
Then Ananta Kumar,
60.29.
come again, 50?
60.
Okay,
60.29.
60.29. Surender,
59.47.
59.47. Then Avik Ghosh,
60.24.
60.24. Then Martin,
60.26.
60.26. Then Subir Manna,
60.34.
60.34.
34.
Yeah, then Kirti Tripathi,
60.40.
40.
Yes.
Okay, Tangatamilan,
60.2.
60.20. In all these cases, every time I played a song, right? And there were some variation, and all of them are examples of reproducibility error. And now, out of the 5 songs, which song you liked most? Come on, tell me. You liked all
The
the
first
songs?
one.
Which one?
First one.
First one. Oh,
Rank 4.
Second one.
a lot of fans. Okay. So
I
which
think
one?
Samudra one.
Which one? Which one you want me to repeat?
Fourth.
Fourth
The
one.
Shrivalli.
Okay,
Shrivalli.
Third one.
But,
Second one.
okay, whatever, whoever asking the song, you must dance then. Right. So we'll go for the dancing song, fourth one. Let me see
Yes.
how all of you are dancing. So we go again. 3, 2, 1, and here we go.
तो मामा बन सकता था
Oh, sorry.
तेरी झलक शर्फी
Not this one. This one. 3, 3, 2, 1, and here we go. All right. So for this song number 3, right? We are taking now repeat reading. Song number 3, reading from Vivek Kumar.
39.21.
29.21.
39.
Okay. 39.21. And then Hastimal
39.6.
39.60. And then Ananda Kumar
39.52.
39.52. Then Surender
39.47.
39.47. Then Avi Ghosh
38.58.
38.58. Then Martin
40.80.
40.80.
0.80.
Then Subir Manna
39.40. 39.40.
39.40. Then Kirti Tripathi
39.10.
39.10. Then Tangatamilan.
39.5.
Okay. Now look at the third song. I have 2 repeat reading. Same song has been heard by each of the appraiser, and each one of them gave me 2 reading. Do you find any difference by the 2 readings given by the same appraiser for the same song?
Yes,
Sir.
Yes, there is difference.
This difference is
There
a
is
measure.
difference.
Yeah, this difference is also an inconsistency. What is this inconsistency called?
Repeatability.
Repeatability.
Repeatability error. The error within Vivek Kumar is also coming into picture. The error within each appraiser you can see, and then there is also error between the appraiser. So there is repeatability error, there is reproducibility error. So how to measure this? And now there are how many appraiser here? 1, 2, 3, 4, 5, 6, 7, 9. So 9 appraiser. So 9 appraiser, then obviously I will have the averages, at least 9 averages, isn't it? 9 averages, and using these 9 averages, if there is a difference in the averages, and that will give a measure of the reproducibility. So this is what we actually discussed earlier. Hope all of you are now able to understand how the error populates. You just cannot avoid, right? So repeatability is the consistency of a single appraiser to measure the same part multiple times with the same measurement system. And that's why operation definition is important. That's why the skill of the appraiser is important. And that's why the using right measurement system is important. And even in spite, if you take care of all those things, still there will be error. And that error can be measured using the standard deviation of the data, right? If you use the standard deviation of the data provided by single appraiser, you get the repeatability measure of it. Similarly, if you use the average of all the appraisers, calculate the standard deviation using the distribution of the averages, that will give you a measure of reproducibility error. So all that we have seen. Yeah, and look here. So generally, precision is the principal concern, right? Inaccuracy due to linearity or constant bias can typically be corrected through calibration. Inaccuracy, you can correct it through calibration, but precision, it's a major concern. You can only control it, can't eliminate it. And now, how do I calculate this precision error? In order to calculate the precision error, first of all, you should know sigma. Once you know sigma, you can multiply by 6 so that total estimate of the error can be understood. But sigma, now you have 2 types of sigma. One is, since there are 2 types of error, repeatability error, there is also reproducibility error. So you have 2 types of sigma here, which you can see here. See here, sigma repeatability and then sigma reproducibility. Now, since there are two sigmas, you should find out the total sigma. When you want to total two sigmas, it won't work in your algebraic way. You have to square the sigmas and then add them and then take the square root, and now you get the combined sigma. This is called standard deviation of the total error. This one is standard deviation of the repeatability error. This is standard deviation of the reproducibility error. This is standard deviation of the total error. Now, what is the total measurement error? This sigma of the error, you have to multiply by 6 now. This will give you an estimate of the total error that may populate when your team is proceeding with the data collection using the measurement system according to your sampling technique and according to your operational definition. So still data was not collected, but we have estimated the error. Still data was not collected, we estimated the error by doing a small study, what is called measurement system analysis. Now the 6 into sigma of the error is the total measurement error. We are going to call it as precision error. This precision error should be compared against the tolerance. What is tolerance? USL and LSL. What is USL? Upper specification limit. What is LSL? Lower specification limit. You know your working range, isn't it? Your range is 100 plus or minus 0.5. And so you know USL, you know LSL. And what is the difference between USL and LSL? 100.5, 99.5. The difference is 1, maybe 1 mm or something. And 10% of that tolerance is what permissible as error. And we'll see that in the next slide. See here. If that precision divided by the tolerance. Precision is 6 times sigma of the error. Tolerance is USL minus LSL. That ratio is called precision tolerance ratio. That precision tolerance ratio is otherwise called as gauge R&R. Is otherwise called as gauge R&R. If this gauge R&R is less than 10%, your measurement system is considered good. If it is 10 to 30%, conditionally acceptable. If it is more than 30%, unacceptable. If it is more than 30%, unacceptable. So let me reshare my screen. Just a second. I'll change my view. And we will now understand how, what all these things means. This